The purpose of this video is to provide an overview of Jobstreams. The Jobstream is the core object of the AI solution. It's the active mechanism that collects runtime data for a subset of important batch processes, automated by the scheduler so as to produce predictive runtime analysis, statistics, and averages, and activate monitoring and supervision tools like SLA management and alerting. We isolate a set of jobs executing in sequence by selecting a target job. AI collects runtime data for that job and its direct upstream predecessors as a job stream and uses the aggregated data to build performance models for our IT operations. The target job is the main point of integration with the scheduler. We're looking to collect runtime data on a specific process and its predecessors, and so the target job plays a vital role in managing job streams. We'll provide a brief overview of what it means to select a target job. Finally, we'll describe some of the tools associated with the job stream, like SLA configuration, alerting, the Gantt view, and more. We won't spend excessive time on these features since they'll have their own dedicated modules. In AI, a job stream is mapped to a target job. The target job should be the last job in a batch process supervised with an SLA. A service level agreement is like a deadline. It's a commitment to have a batch process complete by a certain time or within a certain time frame. If the batch process goes over, we've missed the SLA, which triggers behaviors like alerts. The job stream's target job is the last job in the supervised batch process. It monitors the overall runtime of the process running that job and all of its direct predecessors. Let's use an example. The scheduler automates the execution of a complex sequence against some sort of application, which we've modeled as a workflow. It shuts down an application, runs a backup, contains several technical jobs that perform various tasks, and finally executes a database update before restarting the application. IT operation decides it wants to supervise this portion of the batch process, is particularly interested in the stream of jobs that shuts down the application and runs the updates. By contrast, it has no interest in anything that executes after the update, like the tech job or the restart, or these unrelated processes that are not direct predecessors. We create an AI job stream and select the update as the target job. The job stream monitors the relevant portion of the workflow, and all other processes are excluded. We start in the AI interface. We have 5 tabs at the top, and job streams can be created in several of these tabs. We'll use the Analysis tab, where there's an opportunity to select a business area, which is one method of cataloging job streams. Below that, there are buttons to add, delete, and edit job streams. We create a new one. A job stream must be mapped to the stream of sequential jobs it supervises in the scheduler, and so we define the target job, which is the last job in that stream. All configuration objects are extracted from the scheduler on a regular basis and reflected in AI. The update job, which marks the end of the application update monitored by IT operations, will be here. We enter a text string that matches the condition set in the dropdown, which produces a list of jobs. We look for our update job. We have several update processes in the scheduler. Selecting individual instances of the job doesn't make much sense, since we're looking to supervise a critical job in its larger context, the overall process running against the application. So we use the parentage table to find the appropriate instance. We select the update job running against the DB batch. The job stream has 3 options. You can make the resulting data available to monitoring and alerts functions or not. You can also include it in AI's forecasting functions. Without the second checkbox, AI will only monitor and predicts in-progress job stream runs. If you want AI to forecast future runs, you should check this box. Finally, if you make the job stream critical, then you'll be able to filter your monitoring views for critical job streams only. We click More. We have tabs. In general, we can set or change the business area. Trimming and start job are covered elsewhere. In description, we can free text a description of the job stream, and in alert criteria, we define alerts for the job stream. This will be covered elsewhere as well. The newly created job stream sources the execution history of the process and builds itself from those records. In certain cases, you might have hundreds of executions of the job over the past 30 days. You may want to limit the intake volume, primarily to limit the amount of data retained in the AI database. So instead, you can point to a more recent date and place a limitation on the number of runs you want to consider. You can also set the number of runs to retain, either a value in days set in the configuration settings or a custom number. AI will automatically remove all JobStream runs older than the data selected here. We close and look at the resulting analysis. This is the analysis, which we can also see with the Gantt view. It shows the container, the target job and all its predecessors, critical path links, and the external dependency predecessor. Right away, you notice that the update job and its predecessors are included in the job stream, which will be monitoring the jobs. The successors and unrelated processes are left out of the job stream. This particular predecessor is not included because it has a different execution frequency and was removed automatically with our auto trim features. Trimming has its own dedicated module. Let's edit the job stream. The name of the job stream defaults to the target job name. It's important to rename the job stream to something more helpful. Jobs are named by development teams based on cryptic nomenclatures and arcane naming conventions set by dev teams. AI is not intended for the development community, at least not primarily. Monitoring and supervision are the purview of the ops teams, and aggregated reporting and dashboarding functions are intended for managements. Neither group understands technical job names set by owners, so you should implement a job stream naming convention that makes sense. Let's consider the tabs, trimming, and start jobs will be covered elsewhere. We use late criterion to define SLAs and alert criteria to define alerts. These will also have their own dedicated modules. Let's look at the monitoring and dashboard tabs. The monitoring view provides a live view of ongoing job streams. You start to see the predictive capabilities of AI. For a given job stream, you see the current status, either active or ended, the relative status, on time, early or late, or not predicted to finish, the runtime deltas, start times, predicted end times, and so forth. The view is well suited for ops teams that use AI as a monitoring solution. Monitoring is organized around business areas. The dashboard view is better suited for executive and management teams. It shows similar data sets, but aggregated for volumes for each business area.